Hello, Enriched Chemistry. Oh, I miss you peeps. I have so much fun with you guys. It's just not the same. So it is what it is. So here's where the rubber hits the road kind of thing. So for Enriched, you'll have an extra little topic for each unit compared to the standard kiddos. And so our extra topic that you guys are doing for solutions has to do with complete and net ionic equations. But before we get going, since you're having to do extra work, you get an extra joke. So, did you hear about oxygen's date with potassium? It went okay. Pretty awesome, right? Woo! That's part of chemistry, those chemistry jokes. I'll keep them going, so don't worry. You won't miss out on those. So what we're looking at today is how are net ionic equations written for single and double replacement reactions. So what the heck is a complete ionic equation? Once you write the chemical equation, you're going to check to see if there are ionic compounds dissolved in water. So these are the ones that are labeled AQ. So if you remember in your last lesson, we used solubility table or rules to help us decide what compounds dissolve in water. So what's different from a regular chemical equation to a complete ionic equation is that you're going to go back and rewrite any aqueous compounds as individual ions with the charge. If the compound is not AQ, so if it's a solid, a liquid, or gas, we leave it alone. So here's an example for you. Potassium chromate reacting with lead nitrate to form lead 2 chromate and potassium nitrate. So using solubility rules, we could determine that, hey, lead chromate is a solid and potassium nitrate is aqueous, so we've got ourselves a precipitate reaction. So that's a normal, regular chemical equation. A complete ionic equation, what we do is anything that's AQ. So anything that is AQ, we rewrite separately as ions. So if we look at potassium chromate, there were 2 potassiums. So we write 2 potassium with its charge. Those charges you find on your ion sheet if you don't know what those are. And then here we have chromate. So we have 1 chromate. We've got lead. It took 2 nitrates to balance it out, which means it was lead 2. And it took 2 nitrates up here, so we write that 2 in front. So notice how if there is more than 1, like for potassium and nitrate, we put that as a coefficient in front of the ion. Now, S. If it's S, G, or L, we leave it B. So we write it as it appeared in a regular chemical equation. We only put AQ into ions for complete ionic equations. And then here we've got 2, so we've got 2 Ks and 2 NO3s. That's what it means by a complete ionic equation. Anything that's AQ, we split apart and we write as ions. So once we have a complete ionic equation, we can rewrite that as a net ionic equation. So think about it when you get paid. If you get a paycheck, you'll have your gross pay, and then they'll take out deductions. Things like, Medicare and Social Security tax and federal and state. And so when all is said and done, you get what's called a net pay. So it's what's left after they pull out all the other stuff. Same thing, net ionic equation is what's left when you pull out the extra stuff. That extra stuff is called spectator ions. Spectator ions are ions that are floating around in solution during the reaction, but they don't actually do anything. They stay the same from the left side to the right side. So if we look, notice that we've got 2 potassiums and 2 nitrates on both sides of the arrow. Notice they didn't change. They're exactly the same. We would call those spectators, just like if you're watching a football game or watching a volleyball game and you're a spectator watching it go on, but you're not actually playing the game. That's what a spectator ion is. So in a net ionic equation, what we do is we get rid of the spectators. So think about it like they're pulling your taxes out. So we're getting rid of the spectators. And in a net ionic equation, we're rewriting what's left. And so potassium, so chromate, notice it changed from the left to the right. On one side of the arrow, it is an ion. On the other side, it was in a solid compound. So it actually reacted. Same with lead. And then we don't mess with solids, liquids, or gases. So this is called a net ionic equation. What it does is shows us what's really happening. Because if you think about a solution, when we're doing solution chemistry, so what happens is first we pour some potassium in there, and we've got some chromate floating around, but they're soluble, so they don't do anything. They're just kind of hanging out. But then we pour some lead in there, and we pour some nitrate in there, and for some reason, lead and chromate are extremely attracted to each other. And so when they find each other in solution, they come together and they become a solid. So they're no longer an ion, they're a solid, lead chromate. So that's what's happening. So all throughout this reaction, even though the potassium is there and the nitrate is there, they're not doing anything, they're spectating, they're just hanging out and watching what goes on. We'll go through an example. First, I'm going to do a double replacement reaction, and then I'm going to do a single replacement reaction and show you what first a chemical reaction looks like, then you've got a complete ionic, and then you've got a net ionic. So first up, silver nitrate. Silver nitrate, so I'm going to write that out, with lead chloride and hot water. The reason it says lead chloride in hot water is because lead chloride at room temperature is going to be a solid, but if you heat it up, because solubility increases as temperature goes up, it turns into an aqueous solution. So your starting substances for double replacement are always going to be AQ. Then the ions switch partners, and you're going to end up with silver chloride, and you're going to end up with lead nitrate. And I'm just going to write it down here so I have more room, sorry. And I just used crisscross applesauce and all that good stuff to make sure that my charges were balanced in my compounds. And I need to go back and balance this because there's 2 nitrates on one side and only 1 on the other. And so I got to put a 2 here, which then causes me to put a 2 here. And now everything is balanced. Now, using my solubility rules, I can figure out whether silver chloride is AQ or solid. If you look at your solubility rules, halides, which chlorine or chloride is one, is always soluble except when it's paired with lead, silver, and mercury. So this one is going to be my solid. Nitrates are always soluble. There's no exception, so this is going to be my AQ. That's a regular chemical reaction. Now to do a complete ionic, anything that's AQ, I'm going to split up and write as an ion with a charge. So silver nitrate, there are 2 silvers and 2 nitrates because that 2's in front. So it's going to be 2 silvers, and silver is a +1. And 2 nitrates, and notice I'm writing it with the charge. You have to write the charge with those to show that it is an ion. And then I've got lead. Lead is a +2 because it took 2 chlorines to balance it out. Oh, and it tells you. And then notice there are 2 chlorides, so I have to pull that 2 in front to show that there are 2 chlorides. So anything that's with AQ is rewritten as an ion with its charge. On the right side, we first run into silver chloride, and it has an S. Anything that's S, G, or L does not change. We keep it together. So it is not dissolved in water. It is an actual compound. It's not made up of, it has ions in it, but we treat it like it's a whole substance. And then We've got AQ for our lead, so we're gonna do lead plus 2, and there's a 2 here, so that means there's 2 nitrates. So that's called my complete ionic equation. And to get the net, what we do is we get rid of the spectators. The spectators are the ones that do not change from the left to the right side. They stay an ion. So if we look, the 2 that stay an ion are our lead and our nitrate, because silver became part of the solid silver chloride, and so did chloride. So those changed. So if we would say that nitrate and lead are our spectators. So to write the net ionic equation, what we would do is rewrite it without the spectators. So it's really important that you have a charge on the ions, and for the substance that's either a solid, gas, or liquid, make sure you don't break those up, and make sure you also label those so you can see that it's not AQ. Now if we look, we've got 2, 2, and 2, and we always like to write our equation as the lowest whole number ratio. Essentially it's a 1 to 1 to 1 to 1. So we need to, whoops, grab the wrong one. Oh, come now. Well, those are supposed to erase, but it's like being cranky. Let me try it one more time. There we go. It's a learning curve for me too. I've been making lots of mistakes. So be kind. There we go. So we've got silver plus chloride, which then gives us silver chloride. That's our net ionic. We'll go ahead and do a single replacement reaction. So here we're asking you to take magnesium metal. Metals are solids at room temperature except for mercury. And we're reacting it with silver nitrate. All nitrates are soluble, so that's going to be AQ. So this is like when we did our are you hot or not experiment. So when we have a single replacement reaction, the one by itself, if it's a metal, replaces the other metal. Magnesium is higher on your activity series charge, so this would happen. So silver gets dumped. Oops, didn't mean to do that. Silver gets dumped. And then we end up with magnesium nitrate. And that's going to be AQ. Now I'm going to go back and I'm going to balance it by putting a 2 in front of the silver and a 2 in front of the silver nitrate. That's a regular chemical reaction. A complete ionic, anything that's AQ gets split up. If it's a solid, liquid, or gas, we keep it the same. So magnesium is a solid, so we do not change it. However, silver nitrate is aqueous. And there's a 2 here, so it's 2 silvers, and we put the charge to show it's an ion, plus 2 nitrates. And then again, silver on the right side is a solid, so we do not change it. We leave it the way it is. And now we've got magnesium is aqueous, and nitrate, there are 2 of them, is also aqueous. So we rewrite those as ions. Now we look to see if there's spectators at all. In a single replacement reaction, you will only have 1 type of spectator. In a double, you'll have 2. So if we look, going from a solid to a charge, that is a change. Going from a charge to a solid, that is a change. The only one that did not change was your nitrate. That is your spectator. And so if we were to write the net ionic equation for a single replacement, we're going to have magnesium as a solid plus the silver ion, which then reacts to form the silver solid plus the magnesium ion. Because really what's going on in most single replacement reactions is you've got electrons transferring. So what was originally a solid changes into an ion. What was originally an ion changes to a solid. So there you have it. For your homework then, or for practice, I added a practice quiz for complete and net ionic equations for you to work on. If you would like some more practice, what you could do is, just take a couple of those double replacement reactions off of your practice sheet and see if you can write a complete for them, and then see if you can write a net ionic for them. You can do the same thing for the single replacement reactions that we did previously. And yeah, so the difference between your quiz, your reactions quiz, and the standards quiz is you're gonna do everything they did, but then you're gonna have to do a couple questions on complete versus net ionic and spectators. So there we go. Really don't wanna lose you guys feeling like you're a class, so feel free on the stream if you come across some cool science, or you do some science, or hey, maybe you got some rockin' TikTok video that you want to post, please feel free to post that on the stream. What we'll do is we'll kind of keep it separate. So the stream will be for like communicating, feel free. I want you guys to still feel like a class. Just keep it clean. You know what I mean. No drugs, no alcohol, no sexual stuff. You know the gamut. And then under classwork, that's where I'll have it organized by week, what your assignments are, if there's a video to watch, what you need to turn in. It'll help a lot to download the Kami extension on your Chromebook. Then if you want, you can use text boxes, or you can write right on the surface of your Chromebook, and then you don't have to try printing off stuff and then take pictures of it and uploading it. So it'll just save you a lot of time. Plus it's kind of a really cool tool. If you have any questions, email me. I'll get back to you within 24 hours during the week, on the weekends by the following Monday. I'm also gonna post some office hours, so that way if you wanna do some Google Meets so you can actually see each other or see me, if you have questions, that's also gonna be an option. Otherwise, hey, we're in this together. It's a whole new world, let me tell you. It's a learning curve. Please forgive me, I'll forgive you. And we'll make it through, and cross our fingers that I get to see you in person on May 5th. Bye, Scarlets.